Hello everyone, my name is Heather and I'm hosting today's webinar. This webinar is being recorded and will be available to watch once we're finished on our Recovery Zone website. We have Sheona King speaking today, who is here to set the record straight about the huge amount of information that is available to do with nutrition and sports performance. Sheona has an MSc in human nutrition, so is well qualified to give us her take on things like how we can get the most out of our sports performances with sensible food choices, whether we need to carb load for longer workouts, and how protein affects muscle mass. If you have any questions during the webinar, please type them into the chat box, or you can save them for the end and pop on your mic to ask a question. If you can keep your mics and cameras off for just now while Sheona is speaking, that would be great. And I'll pop back on at the end of the webinar, but for now, I will hand over to you, Sheona.
Thanks very much, Heather. So I have some slides to share today, so I will just try and bring those up for you this now. There we go. So just a second. There we go. Heather, can you just tell me if you can see that okay?
Yeah, we can see it. That's it.
Perfect. So I could be here for hours talking about sports nutrition because it's such a vast subject. But I've just focused on three main areas today. So the first is around maximising energy with long duration endurance training. So things like marathons, triathlons, potentially even half marathons. So we're mainly going to be talking about carbohydrates. Secondly, we will be discussing whether exercise can help with weight loss. And finally, looking at whether people who are strength training need extra protein. And I guess these are all quite common questions that my clients ask. Sometimes they can get confused about. So hopefully it'll help to hear what the latest recommendations are. So I really love this quote from Jack LaLanne. Exercise is king, nutrition is queen, put them together and you've got a kingdom. So in other words, you can do all the right training and all the right exercise, but if you don't consider your nutritional strategy, you'll never get the best results. So all food that we can consume belongs to one of the main food groups. So we've got fats, proteins, and carbohydrates. And of course, most food contains a mixture of these. Certainly most meals that we eat will contain a mixture of all three. What happens to these food groups inside the body? I think there's one thing that's important to point out when it comes to digestion, metabolism, and storage, and that's that nothing is ever stagnant. So there's this constant flow of fats and proteins and carbohydrates going in and out of cells in the body. It's kind of basically like a busy factory with lots of different production lines that operates 24/7. So fats, the most energy dense of the three, can of course be stored in almost unlimited properties or unlimited storage. And fats are an essential part of our diet for many different reasons, having lots of beneficial properties. Some fat can be used straight away as energy, but in terms of storage, most fats are digested, absorbed, they're broken down into their constituent parts. They're called triglycerides and glycerol, and transported to the fat cells. Carbohydrates, so we're talking here about starchy foods like bread, pasta, potatoes, rice, but also sugars, can either be used for energy right away or they can be stored too. So all carbohydrates, when they're digested and absorbed into the bloodstream, are broken down into simple sugars. So we've got glucose, galactose, lactose, fructose, basically anything that ends in an O's. And then ultimately glycogen, and glycogen is a form of glucose. So there are glycogen stores in the liver and in the muscles, but the storage capacity is limited. So I kind of like to think of it as two buckets with some holes drilled into the bottom. So every time we eat carbohydrates, we top up the bucket, but every time we use energy, it requires some glycogen to be leaked out. If we put too much carbohydrate into the buckets, what do you think happens? Well, yes, the excess will get converted to fat, and that will get stored in the fat cells. But if the bucket runs empty, we need something else to make energy or to provide glucose for our energy requirements and our brain function. So that's mainly going to come from the uptake of those triglycerides in the fat cells and using them to produce energy. But potentially we might also need to use some of the protein in our muscles, in our tissues, in our organs. And again, the protein can be used to produce energy. Protein, so we're talking meat, fish, dairy produce, eggs, beans, pulses. Proteins cannot be easily stored in the body. So when protein is digested, it's broken down into its constituent parts. So those are amino acids, and there are 20 different types of those. Those amino acids are then used to build other proteins, including muscle tissue in the body, kind of just like bricks could be used to build a wall. And I'm going to come back to that analogy a little bit later on. Proteins in the tissue of the body are continually being broken down. So kind of imagine someone is constantly breaking down part of that wall with a sledgehammer. And that's simply because the amino acids, the bricks in the wall, become old and inefficient. So in fact, half of your total body protein is broken down and replaced around about every 150 days. The amount of protein required by an individual on any particular day should therefore roughly match the amount of protein the body needs on that particular day to replace the breakdown of the old protein. So in other words, we kind of need to achieve protein balance, and what comes in should match what goes out. And if you're exercising, you will need more protein. We're going to go into that in a bit later on, but it's important to realize that you can't store protein or the amino acids that they're broken down into anywhere in the body and kind of use them later. So if you consume more protein than you need at any one time, then the nitrogen from the amino acids gets cleaved off, it gets excreted via the kidneys as urea, and the other components can be synthesized into glucose, or they can be synthesized into triglycerides. So in other words, they're potentially used for energy or stored as fat. Okay, endurance training. So what do we mean by that? So endurance exercise, which I've classified here as exercise that lasts for longer than around about 1.5 hours. So it obviously requires the human body to produce quite a lot of energy. So where does that energy come from? So you might remember ATP and the Krebs cycles, or sometimes called the citric acid cycle from biology at school. Don't panic, we're not going to go into this today, but it's just a wee reminder that energy is released when one of the 3 phosphate groups, and they're represented with the pink pi molecules in the picture here, in ATP, that's adenosine triphosphate, split off to form ADP, which is adenosine diphosphate. So it stands to reason that more ATP must be produced as the energy demand increases. So where does the ATP come from? Well, it comes from a series of chemical reactions that mainly uses oxygen and glucose. So therefore, the more ATP that's required, the more glucose is required. And where does that glucose come from? Well, it comes from small amounts of sugar and fat circulating in the blood or potentially in the muscle tissue. But it mainly comes from around about 5 up to 500 grams of carbohydrates. So that's from our sugars and starchy foods, which are stored as glycogen in the liver and muscles. And that gives you roughly 1,600 to 2,000 calories of energy, which is, depending on the intensity, about the equivalent of 1.5 to 2 hours of intense exercise. Like we said before, energy can also be produced from the uptake of stored fat from fat cells, and also from the breakdown of protein. And those enter that Krebs cycle in slightly different ways and slightly less efficiently, but they can be used to produce ATP. So when someone is exercising at any given intensity for any given individual, there will always be a mixture of fats and glycogen being used to supply the energy. Generally, the higher the intensity, the higher the proportion of glycogen is used. And that's because it can be broken down really quickly to produce energy. So it produces somewhere in the region of 25 to 30 calories per minute. Fats are broken down less efficiently, like we said, so they only produce around 6 calories per minute, and that's unlikely to be sufficient to meet the demands of someone competing, say, at a fairly high intensity in a long duration competition or race. So additional glucose must be consumed either during the exercise session or the race. Otherwise, the blood glucose levels become too low, the athlete will hit the wall, which means they'll no longer be able to produce enough energy to complete their event at the intensity they want to. They'll start losing concentration, they'll start losing their skill levels. So the $1 million question, I guess, is, so how do we maximize those glycogen stores to help prevent this hitting the wall situation from happening? I guess, first of all, it's important to point out that every individual has their own genetic response to exercise. So some people use fat more efficiently, some people use glucose more efficiently, but these energy systems can be trained, just in the same way that our cardiovascular system can be trained to become more efficient. So, for example, some athletes will deliberately train low, like with low glycogen stores, or train high with high glycogen stores, to kind of help their bodies become more adapted to utilizing either fat or utilizing either glycogen for energy. Most athletes will taper their exercise volume in the run up to a long duration event. And there can be a number of different reasons for this, but one reason might be to try and maximize those glycogen stores in the liver and muscles for the particular event or competition that they're taking part in. Combine that with a higher intake of carbohydrates than usual in the days preceding an event. So that's what we might call carbo loading. So the latest recommendations say that during the kind of 36 to 48 hours prior to an event, it's recommended to consume somewhere in the region of 10 to 12 grams of carbohydrate per kilogram of body weight per day. And that's roughly double the normal requirement for someone who sort of exercises around an hour a day. Before an event, so on the day of the event itself, the recommendations kind of are for 3 to 4 hours prior to take 100 to 200 grams of carbohydrate, or another way of putting that might be 1 to 4 grams of carbs per kilogram of body weight. And that has been kind of consistently proven to enhance performance levels by increasing liver and muscle glycogen levels. And the 3 to 4 hours allows sufficient time for most of that meal to be digested. So you're not feeling too full and you're not feeling too hungry either. There are some individuals that need to try and avoid stomach issues. So they need to kind of keep the fiber elements or protein or fat levels low in those meals. but including those kind of helps release the carbohydrate more slowly into the bloodstream. So that in itself can come with a bit of a performance advantage. And then in the 15 to 30 minutes before the event, it's kind of advised to try topping up with a small amount, so maybe 20 to 30 grams of carbohydrate, kind of especially a source that's considered to have a high GI. So what I mean by that is it's rapidly digestible, it increases your blood sugar quickly. So an example would be a ripe banana or some white bread or maybe some sweeties. During a long distance event, whether you will require any additional carbohydrate largely depends on the intensity and the duration. So as you can see here by the graph, it gives an example of glycogen content over time with different intensities. The maximum amount of any single type of carbohydrate, so say for example glucose, that can be oxidized by the muscles during aerobic exercise is around about 60 grams per hour. And that's just to do with the limitations of the glucose transporters in the small intestine. Bear in mind that it takes maybe about 15 to 30 minutes for any carbohydrates that you consume to actually reach the muscles. So a strategy of kind of little and often is probably better than waiting until you feel tired or waiting until you feel like you've run out of energy. If you're doing an event that's maybe more than 2.5 hours and is quite a high intensity, then athletes might want to try and consume a mixture of different carbohydrates. So perhaps glucose and fructose, or another one would be maltodextrin and fructose. And that's because they tend to have higher absorption rates. So they can maybe be absorbed up to 90 grams per hour because you're using some different types of transporters in the intestine to absorb the fructose. The downside of that is that fructose has a lower GI, so it's absorbed a bit more slowly, and for some people it can cause stomach upsets. But the recommendation, therefore, is kind of for long duration events is to try and take on 60 to 90 grams of carbohydrates per hour. And that's roughly the equivalent of 2 to 3 energy gels, or 2 to 3 bananas, or 2 to 3 liters of diluted fruit juice. So maybe in like a 1-to-1 concentration with water, or an isotonic sports drink. But again, the strategy that any one individual uses is something that needs to be included in your training sessions to fully understand what works for that particular athlete. And then after the race is finished, well, you'll not only be relieved, but you will need to refeed. Your strategy will depend on how much your glycogen stores are depleted, how much muscle damage you've got, how much time there is before your next training session, etc. But generally, consuming carbohydrate in the first 4 hours after exercise in the region of around 1 kilogram per body weight per hour will help you to replenish some of the lost glycogen stores. Also, if you include protein, that can really help repair any damage to the muscle fibers. It also helps build mitochondrial protein. So mitochondria are the source of energy production. And an interesting one here is around flavored milk, so like chocolate milk. So flavored milk contains this ratio of carbohydrate to protein, roughly kind of a 3-to-1 ratio. That's basically considered an ideal recovery drink. And there's lots of research being done that is showing endurance athletes that drank chocolate milk after a workout were kind of better able to perform their next exercise session. They had less muscle soreness and better recovery rates. So, and that would be compared to a sports drink or compared to just water alone. Okay, so next section is about exercise and weight loss. So is it possible to lose weight by doing more exercise? Well, the short answer is yes, but a more effective strategy would be to combine a reduction in energy intake, so in other words, what we're eating and drinking, with an increase in exercise or energy expenditure. So I don't know if you've ever looked at how many calories you burn doing exercise, but you might be surprised by how small the numbers are. And these I've just put in here some examples and these are based on a person weighing around 80 kilograms. So the heavier a person is, the more calories they burn for any particular exercise session. And if you look at these numbers here, and then consider how easy and quick it would be to consume those number of calories, the synopsis is basically that you would have to do a lot of exercise in order to burn sufficient energy to lose weight, and that is approximately 7,500 calories for around 1 kilogram of body fat. So secondly, just a little note here is to say that a lot of people find that when they try and lose weight by exercise alone, they sometimes find they're more hungry. And so they end up eating just as much as they've burned. However, having said all that, there are a few kind of smart strategies you can undertake that'll try and ensure that the exercise you do has the biggest beneficial effect to help burn body fat. So number one, so as you can see, you might burn more calories from running fast or from playing football, but if you're sitting on your bum for the rest of the day, then the total number of calories burned via exercise in a 24-hour period is going to be quite minimal. So on the other hand, if you have multiple, what we might term energy snacks during the day, so things like several 10-minute walks, maybe hoovering the carpets, mowing the lawn, we need to do a lot of that at the moment, doing a set of squats in the kitchen while you wait for the kettle to boil, then the overall calorie burn could be a lot higher over a 24-hour period. Number two, and you're probably wondering what this acronym means. So some types of exercise continue to burn calories even after you've finished. And that's called EPOC, which is exercise post-oxygen consumption. So in general, the higher the intensity of exercise you perform, the greater the EPOC will be. So you've probably, if you've done high intensity exercise before and you've probably felt hot, you've probably felt your heart rate still elevated for a period of time after. So that's what we're calling here by an increased metabolism, basically, after exercise. So not just burning calories during it. So if you've included things like high intensity intervals, if you've included any kind of resistance training exercise, so that could be kettlebells, bands, weights, even body weight exercises like press ups or burpees, everyone's favorite, the greater the EPOC will be. And there's studies being shown that HIIT training, so high intensity interval training, can actually result in somewhere in the region of 25 to 30% more calories being burned than other exercise forms. So say, for example, spending the same amount of time on a cross trainer or an exercise bike. Number three, our basal metabolic rate. So our basal metabolic rate refers to the amount of calories that our bodies need on a daily basis. And that's before we add in any form of physical activity, and also before we add in the effect from eating. So approximately 10% of our calorie requirements are from the energy required to digest and absorb food. That's in here, it's the yellow section of the pie chart called thermogenesis. So our basal metabolic rate, as you can see, is by far the biggest contributor to calorie burning. Now, there are several factors that affect the basal metabolic rate, but the main two are body weight and body composition. So a heavier person requires more calories to maintain their body weight. And I guess that's why it's harder to lose weight if you've already lost some, because the difference between the amount you need and the amount you're taking in becomes less and less as you get lighter. So it takes more time to reduce your energy expenditure by, say, that 7,500 calories we mentioned before, to lose roughly a kilogram of body fat. Body composition, so we're talking here about the kind of relative proportions of body fat, muscle, bone, etc., also plays a big part in determining your basal metabolic rate. So fat is pretty idle. It doesn't really need a whole lot of input to stay where it is. Muscle, on the other hand, is very metabolically active. So muscle burns calories while you're just sitting down doing nothing. So increasing your muscle mass, and we're going to come on to that in the next section, is a really great way to increase the amount of calories you burn. And I think if you bear in mind that humans reach their peak muscle mass in their late 20s, and then every year there will be a decrease in muscle mass if we don't do anything to halt or reverse that. And the final point is related to overall daily energy expenditure. So on top of our basal metabolic rate, thermogenesis from digesting food, and intentional physical activity, a big contributor to how much energy we use up in a day is actually from unintentional physical activity. And those are the simple movements we don't even consider as exercise. So fidgeting and shaking our legs, even kind of getting up to walk to the kettle or walking to the bathroom, and all these can count, perhaps up to as much as 10% of our total daily energy expenditure. Okay, final section is around strength training here. So protein. The reference nutrient intake of protein in the UK is 0.7 grams per kilogram of body weight of protein per day. And that's the estimated amount to meet the needs of roughly 95% of the population. So in other words, to meet the requirements of the body for protein due to that continual breakdown of protein we mentioned earlier on. But what about strength trainers? So muscle tissue is mainly made of proteins, specifically the myofibrils actin and myosin. So those are the contractile elements of the muscle. So to increase muscle size, and another term for that is called hypertrophy, we need to lay down more protein in the muscle tissue in order to build more actin and myosin myofibrils. So in other words, we want to get as many amino acids as possible to the muscle tissue so that we can build a bigger wall. So how do we ensure that the synthesis of protein in the muscle is greater than the protein breakdown? Well, there are a few different factors. So you can see from the graph here that muscle protein synthesis is stimulated by training. Muscle protein breakdown is also stimulated by training, but synthesis tends to overweigh the breakdown effect. Protein synthesis is also stimulated by consuming protein. So they've called it feeding here, and this will usually more than outweigh any breakdown in protein. So there tends to be overall what we call muscle protein synthesis. Also, in addition to that, eating carbohydrates stimulates muscle protein synthesis and can help reduce muscle protein breakdown by up to 50%. And that's due to the fact that insulin is secreted when we consume carbohydrates. So the latest guidance for maximizing muscle protein synthesis and helping to build muscle mass So we've got, obviously, training is an important effect. I'm not going to go into this in any huge discussion because we're focusing mainly on the nutrition aspects here, but the kind of basic guidelines around training would be roughly 6 to 12 reps for each muscle group, performed to maximal or near maximal effort. We're looking at 2 to 3 sessions per week that equate to roughly 10 reps a week in total for each muscle group exercise. I guess for those starting a training program, there will be an increase in muscle protein synthesis, and that happens immediately. But those amino acids brought into the muscle tissue aren't always used for building the myofibrils right away. So they might be used for repairing damage to the muscle tissue, also for regenerating some of the cells like the mitochondria. But once a training regime has been started, if you want to continue to build muscle mass, then there obviously needs to be that steady increase in the total training volume. So we're multiplying the weight we've lifted by the number of reps, by the number of sets, to work out our total training volume. So in terms of protein ingestion, the newest recommendations, and they're based on a meta-analysis of 18 different studies, is that to maximize muscle protein synthesis, the requirements are around 1.6 grams of protein per kilogram of body weight daily. And that's essentially double the amounts recommended by the reference nutrient intake that we looked at earlier. For some individuals, a higher intake might be recommended, so possibly up to 2.2 grams of protein per kilogram of body weight. An easier suggestion might be to say to include roughly 20 to 40 grams of protein in each meal. Animal and dairy proteins contain a wider range of amino acids, but in other words, they contain all the different types and amounts of brick to build that wall, whereas plant proteins might have lower contents of various amino acids. There's one particularly important amino acid for strength training, and it's called leucine, and it basically acts like a switch that turns on muscle protein synthesis. So let's say it's kind of like the construction worker of that wall. So there are foods that contain high levels of leucine and other what we term branch chain amino acids. So these really act as a stimulus for muscle protein synthesis. They include things like whey, which is why whey supplements are quite popular, milk and egg. And it's thought that there might potentially be a leucine threshold required to achieve maximum muscle protein synthesis, perhaps as high as 2 to 3 grams of leucine per meal. And plant-based proteins usually don't contain leucine, so a supplement might be required for vegans and vegetarians. Other nutrients can play a part either directly or indirectly in muscle protein synthesis. I mean, it's something we don't have time to go into today, but it might be one reason why it's better to get protein directly from whole foods as opposed to manufactured protein supplements. So an example of whole foods that contain 20 grams of protein and the right amount of leucine are 600 mils of 600 mils of milk, 3 eggs, or 85 grams of meat or poultry. And even with the right amount of training and ideal feeding patterns, there will still be individual and genetic responses. So everyone gains muscle mass in different ways and to different extents. So for example, older weight trainers might have increased requirements as you get older, because the older you get, the less easily you absorb protein. You also produce less testosterone, that can have an impact on muscle mass. If you have high amounts of lean body mass, or like if you're particularly muscular to start with, you might want to err towards the higher side of the protein requirement range. And if you're in caloric deficit, if you're on a diet, you might want to need to increase your protein intake, because there's also a decrease in muscle protein synthesis associated with low energy intakes. Okay, so we're finished. Just a brief summary. endurance events lasting longer than 1.5 hours, you want to maximize your glycogen stores before, during, and after event. That helps boost performance and aid recovery. And those energy strategies should be included in your training program. Weight loss, or more specifically, fat loss, can occur with exercise alone, but better to include a reduction in energy intake at the same time. However, consider things like the total energy expenditure over 24 hours by looking at the type of exercise, the frequency, the intensity, and perhaps the effect we mentioned on muscle mass and that basal metabolic rate. Finally, strength training, if it's sufficiently demanding, plus increased protein, can really help to maximize muscle mass gains, and you'd be looking at greater than 1.6 grams of protein per kilogram of body weight per day. At the end here, I've included some links to some further resources. So we've got some websites, some podcasts, YouTube videos, etc. And I think that's me. So thank you very much. Hope you managed to learn something new.
Thank you, Sheona. That was great. I'll definitely be checking out some of those links. Find it really interesting about particularly about the weight loss you were speaking about, how the king and queen of weight loss is you need your nutrition and you need the exercise. They kind of go hand in hand. Can't really do one without the other, or I guess you would get optimal results if you do them both.
Yeah,
but I wonder, sorry, yeah, I just wonder if you can give maybe specific examples of foods that are good for eating if you're trying to lose weight, but you also want to be exercising. What's best for good energy levels?
Yeah, so no, it's interesting what you're saying, Heather, and it kind of over the years, the one thing I have noticed that it tends to be men who want to try and lose weight by doing exercise alone. And sometimes it's not the most successful strategy if you don't include that decrease in intake, because as you saw, you need to be doing a lot of exercise in order to burn a sufficient amount of calories. So in terms of helping with helping to lose weight and exercise at the same time, if you are consuming high amounts of carbohydrate, bear in mind that when carbohydrate is stored in the body, it also stores molecules of water alongside it. So when people start cutting down their carbohydrate intake, they tend to lose weight quite quickly. And that's because you've depleted the glycogen stores, but you've also lost a lot of water from the body. So it's not necessarily that you're losing body fat, but you're losing water and glycogen. But having some carbohydrate is really important, as we saw earlier on, for maximizing not only your energy levels, but also can help with your performance. So we'd always recommend that people never cut out any particular food groups. They can cut them down, but you might want to think about the timing of when you consume those foods. So if you're going to be doing a high intensity training session, maybe think about consuming carbohydrates 3 to 4 hours beforehand. But also making sure you're taking on enough protein, because that muscle protein synthesis can drop when you try to drop your energy intake and when you're eating less often. So maybe upping the proportion of protein that you're eating when you're trying to lose weight can be beneficial. Also, protein acts as a bit of an appetite suppressor, and there's a lot of studies being done on that. So it helps keeps you fuller for longer. So that's another reason why it might be beneficial for people trying to lose weight.
Great. Okay, that's good. Lots to think about. It's not just as simple as eat less, lose weight, do more exercise. You've got to think about your protein and carbohydrates and fats and everything. But it's interesting. I like it.
If it was simple, I'd be a multi-millionaire by now by providing very simple advice. No one's got the magic bullet.
Yeah, that's it. That's it. Well, if there's no more questions, I think we'll leave it there for today.
Super.
Thank you,
Thanks,
Sheona.
Heather. Thank
Thank
you.
you.
Cheerio. Bye.
Bye.